This lecture video is on solving compound inequalities. Here you have to be careful of whether you have the and or the or statement involved, and there's just one little thing that you have to be careful of when you're solving inequalities, and that's when you divide both sides of an inequality by a negative number, the inequality reverses its direction. And this is why. So if you have 2 is greater than negative 5, for instance. If we multiply both sides of this equation by negative 1, we'd end up with negative 2 on the left and a positive 5 on the right. And now you see that negative 2 now is less than 5, and this will always happen, and it doesn't matter what negative number you multiply or divide by. Multiplication or division by any negative number will result in the inequality reversing its direction. So you just have to be careful and remember to do that while you're solving. Otherwise, it's just like solving a linear equation. Our first example, x plus 3 is greater than or equal to 4, and 5x minus 2 is greater than or equal to 8. So you solve each of these inequalities. The first one, we would have to subtract 3 from both sides, and we would get x is greater than or equal to 1. Also solve this one, so we would add 2 to both sides. That gives me 5x is greater than or equal to 10, and then divide both sides by 5. And we get x is greater than or equal to 2. And you only reverse the direction of the inequality symbol when you divide by a negative number, not a positive number. So now you want to graph both of these inequalities on your real number line. And we'll do the first one in black. X is greater than or equal to 1, so we use a square bracket because of the equal sign, and greater than means everything to the right. And then I'll graph the other one in red. X is greater than or equal to 2, so it's a square bracket and everything to the right of 2. And means both this and this have to be true. Remember, and is the intersection of the two sets, and so the part that intersects will shade in blue, and that was just from the 2 on up to positive infinity. Okay, so that was where both of those things are true. You want to graph your solution, so the solution would be the blue shaded part, and then also give the interval notation, which is from 2 to infinity. And our next example here, we have negative 5x is less than negative 15, and x minus 15 is less than negative 10. So the first inequality, we want to divide both sides by negative 5. So the left-hand side will have x. We divided by a negative number, so now I have to reverse the direction of this inequality, changing it from less than to greater than. And negative 15 divided by negative 5 is 3. For this one, we want to add 15 to both sides. We get x is less than 5. So we'll put our two numbers on our number line, 3 and 5. The first one is x is greater than 3, and it's no equal sign, so we use a round bracket. And the next one is x is less than 5, so we use a round bracket. It's everything that's less than 5. This was an and symbol again, so this has to be true and this has to be true in order for it to be a part of the solution. So we need the intersection, so that's the overlap of our shading. And I'll shade in the overlap with blue. So the overlap was everything between 3 and 5. And we have round brackets on both the 3 and the 5, and that's because there's no equal sign in the inequalities. In our next example, we have negative 4 is less than or equal to x plus 1 is less than or equal to negative 2. So now we want to solve for x in the middle, and whatever we have to do to the middle to get x by itself in there, we have to remember to do to both of these ends. And whenever you have an inequality statement like this, then you always do either the intersection or the union, whichever you end up getting. So we'll take a look at this. So we're going to subtract 1 from both sides. And negative 1 minus 1 is negative 5. And that's less than or equal to x. And it's less than or equal to negative 2 minus 1 is negative 3. So now we'll graph this on our number line. Put negative 5 and a negative 3 on the number line. And basically what this statement is saying is that x is between negative 3 or negative 5 and negative 3. So this is almost always going to be the intersection on these. You always want to read from the letter out to the number. So the first one says x is greater than or equal to negative 5. And then you start from the letter, read out to the number. X is less than or equal to negative 3. And again, you want the intersection. And so it's everything between 5 and 3 is where we intersected. Negative 5 and 3. Negative 3. Square brackets are because we have the equal signs. Okay. On our next one now, we have negative 3 is less than 2/3 x minus 1 is less than 1. Again, we're trying to solve for x in the middle here, so we're going to add 1 everywhere. Negative 3 plus 1 is negative 2, and it's less than 2/3 x is less than 1 plus 1 is 2. Now we're trying to get this x alone in the middle, and so we want to multiply by the reciprocal of 2/3, or that's the same as dividing by 2/3. So negative 2 times 3/2 is negative 3, and it's less than, we divided by a positive number, not a negative. X is less than 2 times 3/2 is 3. So negative 3 and 3 go on my number line. It's going to be everything between negative 3 and 3, with round brackets because there's no equal sign. But we'll graph them individually. So the first one says x is greater than negative 3, so that's everything to the right of negative 3. The second one says x has to be less than positive 3. Hopefully I said that right. So from negative 3 up to positive infinity, because x has to be greater than negative 3. I don't remember if I said the negative on that, but okay. So now whenever you have an inequality statement like that, you always want the intersection, and so it's that part that overlapped. Negative 3 to 3. On our next one, negative 1 is less than or equal to negative 3x plus 4 over 5, and that's less than or equal to 1. Again, we're trying to solve for x in the middle here, so the first thing that I need to do is get rid of this denominator, so I need to multiply by 5 everywhere. And 5 times negative 1 is negative 5, and that's less than or equal to negative 3x plus 4, and that's less than or equal to 5. Now we're going to subtract 4. We get negative 9 is less than or equal to negative 3x is less than or equal to 1. And then divide by negative 3. And negative 9 divided by negative 3 is positive 3. And reverse the direction of this because we divided by a negative 3. And then x, and then reverse the direction of this, so that's going to be greater than or equal to a negative 1/3. So this is basically the same sort of statement that we had before. So we're going to graph this on a real number line. Negative 1/3 and positive 3. This first statement says x has to be less than positive 3, and it's less than or equal to, sorry. And so that's everything to the left of 3. And then this part says x has to be greater than or equal to negative 1/3. So a square bracket and everything to the right of negative 1/3. So again, it'll be this intersection in the middle. That's our solution. So negative 1/3 up to positive 3. So let me just take a look at our examples quick that we went through with the... Okay, so in all of our examples so far, they've either been both of these have been less than or equal to or strictly less than. This last one, they're both, and they don't have to be the same. One of these could be less than, the other one could be less than or equal to. So they don't have to both have the equal sign or not have the equal sign. That's just the way our examples turned out here. Next, we're going to look at some ors, and so this means that this or this can be true in order for it to be in the solution, and so it's the union of so it's everything that ends up getting shaded in these examples. In this first one, negative 10x is less than or equal to 20, or 3x minus 4 is greater than or equal to 2. So the first one we have to divide by 10. And we get x, and we have to remember to reverse this direction of this inequality because I divided by a negative 10. And so that would be greater than or equal to negative 2. And here we need to add 4 to both sides, giving us 3x is greater than or equal to 6, and then divide by 3. That gives us x is greater than or equal to 2. Put negative 2 and 2 on your number line. This one is x is greater than negative 2, and it's greater than or equal to, so we use a square bracket. And the next one, x is greater than or equal to positive 2, and we want the overlap. Oh, sorry, this is or, so we want the union. So anything that got shaded, so from negative 2 all the way up to positive infinity. In our next example, we have x plus 8 is less than negative 1, or 5x is greater than negative 15. So here we're going to subtract 8, giving us x is less than negative 9, and here I want to divide by 5. And that gives me x is greater than negative 3. And again, the only time you reverse this direction is if you're dividing by a negative, and here we divided by a positive. So put these two numbers on our number line, negative 9 and negative 3. This one says x is less than negative 9, so we use a round bracket and everything to the left of negative 9. This one says x is greater than negative 3, so it's everything to the right of negative 3. And the solution is anything that got shaded. So it's the negative 9 to negative infinity part, and the negative 3 to positive infinity part. So negative infinity to negative 9, and then we use a union symbol to join the two sets together, and then from negative 3 up to positive infinity. And our last example, we have 6 times the quantity x minus 2 is greater than or equal to negative 12, or 4 minus x is less than or equal to 10. So you could either distribute the 6, or because negative 12 is divisible by 6, I would just divide by 6 right away and get that out of there. That leaves you with x minus 2 is greater than or equal to negative 2, and then you could add 2 to both sides. And we get x is greater than or equal to 0. You could, like I said, distribute the 6 first, and that would give you the same answer as we just got right now. On the next one, subtract 4 from both sides, and we get negative x is less than or equal to 6. And then we have to either multiply or divide by a negative 1. We'll change the sign of the x. So that gives me x, and we have to remember to reverse this direction, so that would be greater than or equal to negative 1. So put these numbers on our number line, -1 and 0. The first one says x is greater than or equal to 0. So that's everything to the right of 0. And this one says x has to be greater than or equal to -1. And since we had the or statement, the answer is anything that got shaded. So that would be from -1 up to positive infinity. Okay, and that finishes our lecture on solving compound inequalities. Let me know if you have any questions. Thanks.